Hi guys, have you ever wondered how data analysis is performed using Python programming language? Today we're going to be learning just that with the help of Pandas library, and we'll learn everything there is to know about it. Now, what is Pandas? Pandas is short for Python and data analysis. Pandas is a library in Python which is fast, flexible, and used as an open source data analysis and manipulation tool. It is built on top of the Python programming language. So any updates provided to Python programming language will be compatible with Pandas as well, provided that Pandas is also updated accordingly. Now, if you want to learn Python A to Z, we have videos on that as well, for which I'll be providing the links in the description box down below. Now, since we're talking about data analysis, what kind of data does Pandas handle? For that, we'll have to use a Python IDE where we can code. We will be using Jupyter Notebook. To open Jupyter Notebook, we'll have to go to Anaconda Navigator first. Anaconda Navigator takes a bit of time to load. Okay, it loaded. So we'll be using Jupyter Notebook over here. We are using Jupyter Notebook because it is fast and flexible, and it is an open source web application from Anaconda. It can be used to create and share documents that contain live code. Okay, we launch it. So this is how the starting page of Jupyter Notebook will look like. So here, if you want to open a Python notebook, we have to click on New and click on Python 3. The version of Python which we're using is 3 over here. Okay, so first, if you want to use pandas in Python, like every other library, we'll have to import it using the import statement. So the import statement syntax looks like this: import pandas as PD. Here, PD is called as an alias so that we can use pandas easily in our future references. Before moving on, let us see what's on today's agenda. We have what are the different file formats pandas can handle, what are data frames and series, and we'll look at some of the operations on these two. And lastly, we'll perform exploratory data analysis on a dataset. Exploratory data analysis or EDA is nothing but performing initial investigations on data so as to discover patterns or anomalies. Okay, so now that we've imported pandas into Python, let us look at what are the different types of file formats that pandas can process. So there are commonly used file formats such as CSV files, which are comma separated value files, text files, JSON files, spreadsheets or Excel files, and XML files. Apart from these, pandas can also process images, HTML files, PDFs, and documents. So now let us look at how pandas can read CSV files. A CSV file is something that will look like this. So each value in the file is separated by a comma, and each record or a row is on the next line. So one line indicates one row. I think there are around 11 rows including the headers. So let us see how does Python read CSV file using pandas. So the syntax for that is pd.read CSV and the file name, and keep in mind that this is the home page of Jupyter Notebook and the directory starts from here. So any file which is here can be read by the notebook easily. So let's give the file name, which is employee underscore CSV. And you press shift enter. I haven't given the file extension over here. So now it will work. Yeah. So here we can see Maria Gonzalez and her employee ID and everything else. That's what is there in the data frame as well. Apart from the column header and the rows, there's one extra thing called as the index. So index is automatically given by pandas. The range ranges from 0 to the length of the whole thing minus 1. So if there are 10 rows over here, the index will range from 0 to 9. That's 10 minus 1. So this is how a CSV file is being read using pandas. Now let's move on to Excel file. So the syntax is almost similar, just the CSV changes to Excel because it's a spreadsheet file. So it will be pd dot read Excel, and the file name, of course, which is employee excel.xlsx. We should give it with the extension because pandas does not read without the extension. So that will be here. Now if you press shift enter, we'll get the same values. And the Excel file also looks like this. So these are the 10 employee values with employee ID, gender, position, department, and the employee satisfaction. Now that that is done, we'll head over to the text file processing. There is no such function for a text file in pandas, so we use the CSV function itself, that is pd.readCSV, and the file name, that is text example that I've given over here. I'll show you how it looks. Instead of the comma separated values, here we've separated it using the spaces. So each space indicates that there's a new value. Let us do that. CSV, and the file name is text example, I believe. Yeah, text example.txt. Now if you press shift enter, oh, what happened? So since CSV is just for comma separated values, it just took all the values as one column since there's no comma in between. So now what we can do is we can add a separator or a delimiter. Separator can be a space since the values are separated using spaces over here. We can use a separator as space. And now if you press enter, oh, it's better than the last one. Now you have not a number over here because the first name and the last name got shifted to the next column as an header. What seems to be wrong in this file is that there is space in between and these two are taken as two different characters or strings. So let's just include a double quote so that it's taken as one single string. And the same thing goes for employee satisfaction as well. Now let us save it and see if it works now. Yeah, now it works properly. So you have the first name, which has Maria, and last name, which has Gonzalez, and there's employee ID as well. And that seems to be perfectly matched with the columns and the rows. Now, since employee ID is different for each employee, we can use that as an index without having this. Since it's automatically given by pandas, we can also use employee ID as an index over here. To do that, we have to use the attribute called index call and give the header name. So header name is employee ID. Now let us see how it works out. The spelling seems to be wrong over here. It's index call. Yeah, so now instead of the index, which is automatically given by pandas, now we have a new index called the employee ID. So each value over here indicates a new row. All the values are different over here. And that's about the different types of file formats which pandas can process. Now let's move on ahead. Coming to the next topic, we have data frames and series. Here we'll be discussing about what data frames are and how do we create them, and also what is a series and what is the difference between a series and a data frame. Until now, we have seen that how DFs are created automatically using pandas. But what if we want to manually create a data frame with the help of two or more lists? This is how we do it. Here we have two lists, name and age, which have the records such as Adam, Rina, Will, etc., and the ages of those people respectively. To convert it to a data frame, first we need to convert it to a list. So to convert it to list now, we typecast it using zip function. zip, name and age, and now we convert it to list using the list function. Store it in a variable called biodata or something. So after this is done, we need to convert it to a data frame. So pandas gives us a function called data frame, which can convert a list into a data frame. The function goes like this: pd dot data frame of the variable, and you can give the column headers as well. So columns can be name, comma, age. We store it into a data frame variable. So now we'll see that how it works. Now if you want to see the data frame, you just shift enter. So here we have the index, the column headers and the values. The index, as you know, it's automatically given by pandas. Now let us see what series is. For that, we'll take the datasets which we've already used before, which is the employee dataset. So here, let's copy it. Now paste it over here. So now if you press enter. Okay, so here the index is employee ID. Now, what if you want to see the employee satisfaction of employees, just those two? We have a function for that as well, which is emp data. Okay, let's save it as emp data because that will be easier. And then change it over here as well. Okay, emp data equals. Okay, if you want to select just the first name and the employee satisfaction, you have to give first name and the employee satisfaction in a square bracket. So now this would work. Okay. So here, yeah. Now since employee ID is displayed because it is the index and the first name and employee satisfaction as we wanted. So now moving on to series, we'll check what is the data type of this thing first. So here it says pandas.core.frame.dataframe. So this shows us that this is a data frame. And now let us check what series is. So here we didn't get a data frame like structure because here only one array is there, and with that the index. So series is basically a array plus the index. Array is a 1D array, one dimensional array. To define series again, series is a combination of a single array with an added index. Now if you check the data type of this, which is emp data again, data of the whole thing of employee satisfaction. So we'll get series. Yeah. Now if you want to display all the indexes of this particular series, we have syntax for that as well, which is series dot index. Before that, let us store this value in a variable called series. So let's execute this. Let's just execute this now. Yeah, here, so it displays all the indexes over here. So the first index is 198829991, and here also it's the same thing. Now if you want to access one particular value using this index, we can do that as well using series of series square bracket and then a particular index. Let's say we take one from the middle. Let's just put it here. Now if you press enter, we'll get the rating as 3. Let's just check if it's right or wrong. 15010. So here, yeah, it is 3. So we get the right answer. Moving on, now if you want to perform any operations on data frames and series, some of the most commonly used functions are, so if you want to get information on the data frame, we can use .info function. It gives a brief description of the data frame. So here you can see the index or the number of values and the column names. Here, first name, last name, sex, position, department, and employee satisfaction. And here we don't have any null values inside the table. So we don't have any null values over here. Everything is non-null. And data type is an object for first 5, and the employee satisfaction, since it's an integer, we have int 64. And now if you want to display just the first 5 rows of a data frame, we can do that as well using the function called head. So mdata.head gives us the first 5 rows of the data frame. Now if you want only first 3 rows, we can do that by giving the value 3 over here. It will display just the first 3 rows. So here we can see only 3 rows have been displayed. Just like this, if you want to display the last 5 rows of a data frame, use the function tail. So here we can get the last 5 values of the data frame. We'll check if this is the same as this one. So the last value is 15010721114. And yeah, it is the same thing, John Smith. So if you want to display the shape of the data frame, you can use the function called data.shape. So emp data here we don't need semicolon because it's just a single function. So total there are 10 rows and 6 columns. Like you can see over here, there are 6 columns and 10 rows. And you can get the size as well, which is dot size. It is nothing but the product of rows and columns. So I guess you'll get 60 over here. Let's just check that. Yes, you get 60. Apart from these, we can display individual row values as well using the location function. So that can be done using location of employee data with, like, say we want to display Michael's row. So the first name should be given over here, that is Michael. Employee data of first name equal to Michael. So yeah, AEL, I think that's right. And you gotta use employee data here as well, since we are using this function on this data set or a data frame. Now if you execute this, we'll get 2 values since there are 2 Michaels in our data set. And now if you want a particular value to be displayed, like say a particular index value, we use the function iloc, the index location. So that is dot iloc of, let's say, the third value. So that's 2. The third value is Jessica. So let's try to do that. Log of 2. Yeah, you get it. So the first name is Jessica and the last name is Bunbury, and the rest values. So you can sort a data frame as well using the sort by values function, which goes like this: emp data dot sort by values, sort underscore by underscore values. No, it's just the sort values function. There is no by in between. Sorry. Sort values function. Over here we get by. Like, how do you want to sort it? On which condition do you want to sort it by? So here, let's just sort it using the employee satisfaction, since that's the only numerical value which we have. Sort by employee satisfaction. Employee satisfaction. And let's say if you want to sort it using descending order, we give ascending is false. Okay, so here we have the values sorted in descending order of employee satisfaction. Now, if you want to sort it in ascending order, you don't have to give this attribute because by default it takes ascending as true. Here we can see that the satisfaction, employee satisfaction, is in ascending order. Now that we've discussed about data frames and series, we'll do an exploratory data analysis on a sample data set. So let's just make a heading with exploratory data analysis. So the data set which I'm going to be using is athletes data set, which has the top earned athletes from the year 1990 to 2020. So for 1 year, there will be 10 athletes and their earnings in millions. Yeah, so here you can see the serial number, name, nationality, current rank, and previous year rank, sport, year, and the earnings. Earnings are in millions. So, for example, you can see Mike Tyson, who's from USA, ranked number one, and the sport he plays is boxing. Year is 1990, and the amount which he earned in that year is 28.6 million. So, let's import it to Python. Path is athletes data .csv. Now you can see that it's imported over here, and we have not number values over here which we will clean in the next step. Now, since there is serial number as well as index, for it to not be confusing, we can use serial number only as index. So that can be done using index call attribute. And we'll store it in a variable called athlete df. Let's just execute this and print athlete df. Yeah, now you can see that the serial number is only taken as index. So now we have some useless values over here. To remove them, we can use this function called drop. So drop, what it does is it removes unnecessary columns in the data frame. So let's just take a variable called useless columns. So a list of what are all the columns which you want to remove. So we can remove previous year rank because there are many not a number values over here. And then use the drop function with the attributes useless columns and axis equals 1, since we have to remove the column. If you want to remove a particular row, we can use axis equals 0. Again, you can use the athlete df variable. Drop useless columns, comma, axis equals 1. Now print athlete df again. Now you can see that the previous year rank is removed over here. So in data frames using pandas, we can also segment data based on particular conditions. For example, if you want to display the records which have earnings over 50 million, we can do that using this. Let's say df of earnings greater than 50. df earnings which are greater than 50, and over here also it should be athlete df. Let's store it in a variable called df1 or something. Now let's check what is the value of df1. Oh, it's stored as df11, so let's just take it as df11 itself. Here you can see that the earnings are above 50 for every player which is present over here. And the same thing can be done for less than equal to 50 as well. So the only change is the condition sign changes over here. Let's just copy this and paste it over here. Let's name it as df12 maybe, and less than equal to 50. Now if you print df12, we'll get all the values which have earnings less than 50, less than equal to 50. As you can see that over here there is values 50. Now another way to do this is using a df query. So what you can do is athlete df dot query, and in the query function what you have to give is, so the column name greater than 50 if you want to display the values which are greater than 50. So that goes like this: earnings greater than 50. So it does the same thing as this function, but the only thing is it consumes less time and it's easy to type. And if you want the same thing to be done on earnings less than equal to 50, so the same thing can be done. df dot query earnings less than equal to 50. So yeah, you can see that it displays all the value which are less than equal to 50. Now if you want to display the records who are from, I mean the people, the sports persons who are from USA, that can be done using equal to condition. So again we write a query, athlete df dot query. Here nationality equal to USA. Since USA is a string over here, we use double quotes. Now if you execute this, we'll get records of all the players who are from USA. So we can see that there are 206 rows. And now if you want to display people who've played sports starting with the letter B, that can be done using the starts with function. So for that, the query looks like this: athlete df dot query sport, since the column name is sport with capital S, sport dot starts with, since we want the values, or the values or the rows with sports starting from B, we'll use the character B with double quotes. And since we're using Python, the engine is Python. Engine equals Python. Python is also given in quotes. And over here, yeah. So now let us see what the output of this query is. We have to convert it to a string first. That's the error over here. So convert it to string and then check starts with. Then now we'll get the output. Yeah. So as you can see, it is displayed all the records which have sports starts with the letter B. And now two conditions can also be used in a single query. So if you want to display the people who are from USA and who have earned more than 50 million, so that can be done using this query. Dot query where nationality is USA, double quotes USA, and earnings are greater than 50. Let's check if it works or not now. Yeah, as you can see, it works perfectly fine. So over here, all the people who are from USA have been displayed and all the earnings are above 50 million. Let's say if you want to sort the values by year, since 1 year contains 10 athletes, we can do that as well. So that can be done using the sort values function. So athlete df dot sort values. Over here you give by which column do you want to sort the values by. So by, and the column name must be in square brackets year. So now if you execute this, as you can see, the year 1990 is displayed first. So let's just make changes to the original data frame itself. So you can store it in athlete df itself. So this makes changes to the original data frame. And now once you print athlete df, you can see that it is sorted according to the year in ascending order. Now let's say if you want to display 20 records, first 20 records, that will have the values like this now. So here you can see that there are 10 records with 1990 as the year, and the rest 20, the rest 10 are also with 1991. It's sorted according to the year. Now, if you want to separate records by year, we can do that using group by function. So that goes like this. Group by is nothing but if you want to segment data using a particular condition or a particular value, you can do that. Like say if a column has many values which are same, we can group those values into a particular or a single data frame. So the group by function looks like this. Since now you want to group it by year, we take group by of year, and then since we are applying this function on athlete df, you do that, and then since we want to display the data frames which are coming out of this, so we use the function called apply of display. You can use print over here itself, but it does not look like a data frame when it's executed. So let's see what the output of this function is. As you can see over here, the data frames are split into 10 data frames, and each data frame has 1 year and those 10 records with the rankings also. As you can see, the year is 1990 over here, and over here it's 1991, and over here it's 1992, and so on. So if you want to do the print as well, we'll check that also once. Let's just leave it here. Copy this. Instead of display, we'll give print. As you can see that this does not look like a data frame, and this is more, aesthetically pleasing compared to this. So that's the difference between display and print over here. Moving on. So if you want to group the earnings with respect to a year, that can be done using the group by function again. So that will look like this. Group by year, and then earnings is outside. So for 1 year, it'll display the mean of that particular year. If like say in 1990, all these 10 people have earned around this much, it'll display 1990 and the mean of all the values which are there in 1990. So that'll look like this. Athlete df dot group by. Let's check what the output is. So here you can see 1990, the mean earnings per million is 12.8, whereas in 2020 that value is around 81.92 million. Now if you want to plot these values, that can be done using the df.plot function. So for that we'll store this value in another data frame called plot df or something. So let's say plot df equal to this, and then execute. Now if you see plot df, let's convert it to a data frame first. So that can be done using the pd.dataframe function of. Now if you execute this and then pd.plot. So okay, so you can see the plotting has been done by pandas itself. It takes automatically the values which are present in the data frame. So over here the values are years. Years is taken on the x-axis, whereas the earnings is taken on the y-axis. As you can see, the difference in values or earnings per year has been pictured out beautifully. Now here you can see that there's no label for the y-axis. So that can be done using the plot function, plot df dot plot x label equals to year, comma y label equals to earnings. So let's see how that works. Yeah, now you can see that the labels have been added for both x-axis and y-axis. Now that brings us to an end of this video. To summarize, we learned what is pandas, what are some of the commonly imported file types using pandas, what are series and data frames, differences between them, and finally, we performed an EDA on a sample athletes dataset. Now, thank you and keep learning. Goodbye.